Functions, Relations and Graphs, Part 2, Learning Objectives. At the end of this instructional video, you should be able to perform mathematical operations to combine functions, adding, subtracting, multiplying, and dividing. Compute the composition of two functions. Convert a many-to-one function to a one-to-one function. Define the inverse of a function. Apply the procedures for inverting a function. Employability skills being infused or highlighted in this video. Accuracy in calculations. Critical and independent thinking. Time management. Creative problem solving.
Now let's look on some operations on functions. This is where we will add the functions, subtract the functions, multiply the functions, or divide the functions. For example, if we have f of x being equal to 2x plus 3, and we have g of x being equal to x minus 1. We may be asked to add the functions. So, f of x plus g of x. We may be asked to subtract the functions. F of x minus g of x. We may be asked to multiply the functions. F of x multiplied by g of x. Or we may be asked to divide the functions. F of x divided by g of x. Now, in evaluating number 1, we are going to add the functions. So number 1. Now, f of x would be equal to 2x plus 3. And we will add to this x minus 1. Removing the brackets, this becomes 2x plus 3 plus x minus 1. Our next step is to combine the like terms. 2x plus x plus 3 minus 1. And you would realize that each term, the sign in front of it is kept. Now, 2x plus x will give us 3x, and 3 minus 1 would give us a positive 2. Next, we want to subtract function g from function f. Again, we rewrite 2x plus 3 minus x minus 1. We will remove the brackets. 2x plus 3 minus x. Now, there's a minus sign here, which would be the same thing as a minus 1. And minus 1 times x will give us a minus x. However, minus 1 times minus 1 will give us a positive 1. Again, we combine the like terms. 2x minus x plus 3 plus 1. This becomes x plus 4. For part 3, we're asked to multiply the functions. So we have 2x plus 3 multiplied by x minus 1. The first step we will take is to multiply 2x by x. This becomes 2x times x, 2x squared. Our next step is to multiply 2x by negative 1. This becomes negative 2x, because 2x times negative 1 will give us negative 2x. Our next step would be to multiply 3 by x. So this would become 3 x. And lastly, our final step would be to multiply 3 by -1. This would be -3. Now combining the like terms like we did before, this becomes 2x squared. These two terms are common. So 3x minus 2x will give me a positive x and -3. So our answer would be 2x squared plus x minus 3. And lastly, we are asked to divide the functions. 2x plus 3 divided by x minus 1. For this answer, we could leave this quotient in this format, since we really don't have anything to cancel. However, if our quotient was 2x squared over x, then you could say x divided by x, and so on and so forth. Another way to combine functions would be to find the composite of the functions. So using our function example from before, f of x is equal to 2x plus 3, and g of x is equal to x minus 1. The composite of f of x and g of x is usually defined as f of g of x, which may be written as f g of x. In other words, we are using the value of one function as the input value for the other function. G of x would be the input value for the f of x function. So everywhere in f where we have x, we are going to input g of x. This becomes 2 g of x plus 3. Now we have to replace g of x by x minus 1. This becomes 2 x minus 1 plus 3. We simplify by removing the brackets. 2x minus 2 plus 3. And lastly, we combine the like terms. 2x, 3 minus 2 would give me a positive 1. So our answer would be 2x plus 1. Now what would happen if instead of using g of x as the input value for f of x, we used f of x as the input value for g? What would our answer be? Let's try. So g f of x. In a similar manner, everywhere in g we have x, we would input f of x. So this would become f of x minus 1. Substituting the value for f of x, this becomes 2x plus 3 minus 1. Removing the brackets, we have 2x plus 3 minus 1. And lastly, combining the like terms, we have 2x plus 2. So when we input g into f, our result was 2x plus 1. And now we input f into g, our result 2x. Inverse functions. Having looked at combining functions previously, we turn our attention to inverting those operations. For example, the inverse of the operation of addition would be subtraction, and similarly, the inverse of the operation of subtraction would be addition. In a similar light, the inverse of the operation of multiplication would be division, and for division, it would be multiplication. Now consider function f, and we let function f be a 1-to-1 mapping, 5, 7, 9 as our domain, and 6, 8, and 10 as the range. 5 maps onto 6, 7 maps onto 8, and 9 maps onto 10. If we wanted to find the inverse of this function, we would denote it as f to the minus 1. Now, the inverse function inverses the mapping that comprises f. So our inverse function would be 6, 8, and 10 being our domain, and 5, 7, and 9 for the range. So instead of 5 mapping onto 6, 6 would now map onto 5, 8 would now map onto 7, and 10 would map onto 9. Now let's look at an example. Given the function f of x is equal to x plus 4, by observation we would realize that to find the inverse of this function, we're basically going to subtract because our function has addition. So we expect the inverse function to be x minus 4. Let us call this method 1. Now method 1 may not work for all functions because this is a simple function. Let's look at another method that we can use. Let's call this method 2. For method 2, we will rewrite f of x as y. So our function, so y would now be our range, our output value. So y would be equal to x plus 4. So this is the first step. Our second step would be to interchange the x and y values. Alright, so we will interchange x and y values. This becomes x is equal to y plus 4. At this point, we want to ensure that we solve for y. Alright, so our third step would be to solve for y. So we have x being equal to y plus 4. To solve for y, we would need to subtract 4 from both sides. So this would be x minus 4 being equal to y plus 4 minus 4. The 4's will cancel, of course, so we'll be left with x minus 4 is equal to y. Therefore, our inverse function would be equal to x minus 4. This corresponds with our answer we got previously, where f inverse x was x minus 4. Let's look at another example. Given the function f of x is equal to x plus 6 over 4, for our inverse function, we will undo the operations. The first thing that was done was that 6 was added to x. And lastly, this sum was divided by 4. For our inverse function, we would start with the last thing first. So, the last thing that was done is a division by 4. We would start with a multiplication by 4. Then, because we had an addition here, we would subtract 6. So our inverse function should be 4x minus 6. And this was method 1. Now, this may not be clear. So, if you desire to use method 2, the first thing you would do is to replace f of x by y. And our function would be y is equal to x plus 6 over 4. Then we would interchange the x and y values. So this becomes x is equal to y plus 6 over 4. Our next step would be to solve for y. This becomes, we want to multiply both sides by 4, so this becomes 4x being equal to y plus 6 over 4, and we are multiplying all of this by 4. These will cancel. We're left with 4x is equal to y plus 6. We want to make y the subject, and so we would subtract 6 from both sides. This becomes 4x minus 6 being equal to y plus 6 minus 6. These will cancel, and we're left with 4x minus 6 equal y. Therefore, our inverse function, f inverse x, is 4x minus 6.
Functions, relations, and graph. Lesson summary. A relation shows the connection between two entities. Mathematically, these entities can best be described as a set of ordered pairs. For example, 1 mapping onto 2, 3 mapping onto 4, or 5 mapping onto 6. The set of the first component of the ordered pair is the domain of the relation, and the set of all second components is the range of the relation. Also, an arrow diagram or flow diagram or mapping diagram is used to show the relationship between these entities. A function is a special relation. A function is a relation in which no two ordered pairs have the same first component, that is, a one-to-one or a many-to-one mapping. And remember, we can combine functions by adding, subtracting, multiplying, dividing, or finding the composite, that is, the function of a function.